Okay, this is your circuit diagram for your project. So I'll first show you, see, these are the components. So I'll explain the individual components to you one by one. First understand this. This is a low beam or one LED. Okay, so this is a high beam. So it is shown with two LEDs. So this particular thing, it is an LED. So this is light going out. That means it is an LED. See, it is a light going out. That means it's an LED. And you see this one component. Okay, this is a light sensor that you are going to install on your car or bus or whatever vehicle. Okay, in this you see the light is coming in. That means it is a light sensor. It takes in light. Okay, and this one LED, it gives out light. Okay, so these are the two components. Other than that, there are other components which I will explain, okay, one by one. See, this is called the OR gate. I will explain the functioning of each component one by one, but for now just see what these components are called. Okay, this is an OR gate. You see, these two look similar. Okay, this is an OR gate. Both of them are OR gate. Okay, this is a NOT gate. Okay, so the names are given here. See, the names are given here. This is a NOT gate. Okay, this is an AND gate. You see, the name is written over here, and here also, and so these two are AND gates. Okay, and this one is called a NAND gate. Okay, so I'll explain the function of each of these components separately, but for now you just understand that these are the names of these components. This is a NAND gate, this is an AND gate, this is a NOT gate, OR gate. Okay, and this is a switch. This is a single pole double throw switch. That is the name of this switch, because one input is there and two outputs that are possible. Okay, when the driver puts the driver can use this switch to put the light either in low beam or high beam. If it is positioned the way it is now, it will be low beam. See, it is pointing towards low beam. If it is positioned like this, then it will be going for a high beam. Okay, so and this is the power source or the battery of the vehicle. Okay, so right now in our circuit diagram, we have not given a switch to turn off the whole system. So we assume that the system is on, and then the driver chooses to put it in either high beam or low beam. Okay, so first, now I will explain each component one by one. Okay, so I will draw and show you this. Okay, so what were the components? First let us see NOT gate. Okay, NOT gate. NOT gate looks like this. Okay, it has got one input and one output. Okay, so what we do in this electronic circuits is, whenever it is on, we represent it by 1, and whenever it is off, we represent it by 0. Okay, so these are digital circuits, so these go in ones and zeros. Okay, so suppose here if the signal is 1, okay, then here the output will be 0 in case of NOT gate. So this is called the truth table. Truth table for a NOT gate. Okay, NOT gate. This is the truth table. Okay, truth table means, see, I will show you how it is. This is the input This is the output. In case of a NOT gate, when the input is 1, the output is 0. And when the input is 0, the output is 1. That is all the function of NOT gate. Whatever is the signal coming in, the NOT gate will just reverse it. Understood? Whatever is the signal coming in, the NOT gate will reverse it. Okay. So now we'll try to understand the other one, AND gate. See, the AND gate looks like this. It looks like a D. Yeah. It has got two inputs and one output. So let's name the inputs as V1, V2 and output as O. Okay. So what does that AND gate do? See, when both the signals are high, when both the signals are 1, okay, then the output will be 1. Okay. If any of the signal is low or any of the signal is 0, the output will be 0. And when both the signals are 0, then also the output is 0. So the AND gate, okay, AND gate truth table looks like this. You have V1, you have V2 and you have output. Okay. So when V1 is 1, V2 is 1, output is 1. V1 is 1, V2 is 0, output is 0. V1 is 0, V2 is 1, output is 0. When V1 and V2 are both zeros, then also the output is 0. Okay, this is the truth table. Okay, truth table means nothing but, this is the way this particular gate functions. These are called logic gates. Okay, and NAND, NOT, OR, all these gates are called logic gates. Okay, so this is how they function. This is how the AND gate functions. When your V1 is 1 and V2 is 1, output is 1. V1 is 1, V2 is 0, output is 0. V1 is 0, V2 is 1, then also output is 0. When both of them are 0, then also the output is 0. Okay, 0 means off. Okay, 1 means on. You take it like that. Okay. Now the other component that we are going to see is NAND gate. NAND gate is nothing but a combination of AND gate and NOT gate. It is represented by this. See, almost looks like AND gate, but only with a small circle after that. So here again, let's see, the input voltages are V1 and V2 and the output is O. So how it functions? In case of a NAND gate, when V1 is 1 and V2 is 1, okay, the output will be 0. It is just opposite to what the AND gate does. See, I'll show you. See, this was a case of an AND gate, right? V1 is 1, V2 is 1, output was 1. But in case of NAND gate, it will be just opposite. So it will be 0. In case of AND gate, it was when V1 was 1, V2 was 0, output was 0. But here, in case of NAND gate, it will be 1. Others also, like this is 0, this is 1, the output is 0 in case of an AND gate. But in case of a NAND gate, it will be 1. Okay. When both the inputs are 0, in case of AND gate, the output is 0. But in case of a NAND gate, it will be 1. Okay. So I will just show the draw the truth table here. Okay. Yeah. So this is called NAND gate. Truth table. Okay. So this is how it will look like. So we have again V1, V2 and output. Okay. So when V1 is 1, V2 is 1, the output is, Laya, output is, in case of a NAND gate, output is, say something. 0. So output is 0. When V1 is 1 and V2 is 0, output is 1. V1 is 0 and V2 is 1, then the output is? When V1 and V2 are 0, then the output is? 1. So this is what gate? NAND. This is the NAND gate. Okay. So now what we are left with is OR gate. Okay, OR gate, it is represented like this. Okay, this also has got one output and two inputs. This is an OR gate. V1 and V2 are the inputs. This is the output. So how is the truth table of OR gate? How it functions is that if V1 or V2, okay, any one of them is high, that means any one of them is 1, then the output of the OR gate will be high or output will be 1. In all other cases, the output will be 0. So let's see how the truth table looks like. This is OR gate. Okay, and this is the truth table. Truth table. Okay, so let me draw it. Let me draw the truth table here. Okay, we have V1, V2 and output. So what is V1? V1 is 1, V2 is 1, output is, Radu, output? 1. V1 is 1 and V2 is 0, output is?
1, 0.
This is an OR gate.
I didn't hear what you told.
What I told. In case of OR gate, the name itself implies V1 or V2 is 1 means output is 1.
Okay.
Okay. V1 or V2, anyone is 1 means output is 1.
Oh.
And when both are 0, then what is the output?
0.
0. Okay. This is OR gate. This is how these gates that we have used in our circuit, this is the way the gates function. Okay. So there are many other logic gates, but for now, for our circuit, these are the 4 gates that we are going to use. Okay. Okay. These are the 4 gates that we are going to use. You can check this. Okay. NOT gate, AND gate, NAND gate and OR gate. See, our diagram has only these things. NOT gate, AND gate, NAND gate and OR gate. Okay. These are the only gates, logic gates that we have. Okay, so wait a second, I'll open it in a way so that I can draw on top of it. Yeah, so now I'll draw on top of it and then I will show you. Okay, so come here, and take this, the red marker. Okay, now see, now we are going to simulate various conditions. Okay, I will show you one simulation, how it is done, and the rest I will send a copy with Laya. Okay, in that you will see other simulations. Okay, now see, the driver has put it where? In the low beam side. Okay, this is the low beam side, this is the high beam side. Okay, this high beam side of the switch, this is the low beam side of the switch. Okay, now see, there is no switch in between, so V1 is always 1. Okay, V1 is always 1. V1 here also, for the light sensor also, is always 1. Okay, let me first tell you how the light sensor works. Okay, it functions in a way opposite to that of an LED. See, how a LED functions is, when you pass a current through it, then it will give the light out. Okay, first you pass the current and then it will give out the lights. Okay, in case of a light sensor, what happens is, the current comes and waits at one side, but when you strike it with a light source, okay, that time it will let the current to pass. Understood? If you keep a light sensor in the dark, it will not conduct any current. You understood? So right now, let's assume that where is this light source placed? This light sensor placed. It is placed in such a prominent area where, if there is an opposite vehicle coming, its high beam will hit you, or its beam will hit you. Okay, on this sensor. Okay, so right now, there is no vehicle coming opposite, so this light sensor is actually not conducting electricity. Okay, so now the driver has positioned this light in the low beam side of the he has positioned the switch towards the low beam side. Okay, so what happens now? This is 1. Okay, V1 of the switch is 1. Okay, V2 becomes 1 because this is now connected, so V2 becomes 1. Then this V2 makes this V2 equal to 1. Okay, the moment this V2 becomes 1, what happens? This is an OR gate, right? This is 1 and this is 0. For now, this is 0 and this is 1. So output becomes 1, V3 becomes 1. This V3 is now the input to this OR gate 2. So this one will become 1. When this becomes 1, this side there is no power flowing, so we mark it as 0. So what happens? The output becomes 1. Okay, the output of the OR gate becomes 1. That 1 means current is flowing through this. So this LED will light up. Okay, this LED will light up. Okay, so the low beam light is on. Okay, now see what happens. Suppose if you are going on a low beam and there is another vehicle coming from the opposite direction, and he hits you with his beam. Okay, so this one will start conducting. This sensor will start conducting. When this starts conducting, this 0, what happens? This 0 becomes 1. Okay, but you know what? This is an OR gate, so the output doesn't change. So this remains 1, this remains 1. Okay, this remains 1, and the low beam is still on. You got it? So no change happens, because you have to have the low beam at least when you are driving, right? Driving at night. So even if yeah, I mean when you are driving in a low beam, even if someone hits you with his beam on your car, then also the low beam doesn't change; it remains as it is. Understood? The low beam remains as it is. Okay. Okay. Now we will check other scenario. Okay. Wait a second. Let me erase this. Oops. Okay. Okay, so now again we have come back to the same drawing. Now let us see a case when you are driving with a high beam. Okay, that means the driver has positioned this switch like this. Okay, now this is not there. Okay, this is not there. The driver has positioned the switch like this. So what I said before, this is always 1 because we don't have a switch in between to turn on and off, and here also we have the input to the light sensor as 1. Okay. Now see, this one is going to be little interesting. Okay. Now since this is 1, V1 is 1, V3 also becomes equal to 1. Wait a second. V3 also becomes equal to 1. Okay, this V3 becomes 1. Now this is 1 means all these things are 1. Okay, this one is 1 and this one is also 1. Understood? Okay, this one and this one is 1. Okay, now see what happens. Not only that, this is also 1. Wherever you see a loop like this, you see a loop like this, that means the wires are not intersecting. See, there is a loop, the wire is not intersecting. See, at these places there is a loop, that means the wire is not intersecting. Okay, they are just going on top of each other but not intersecting. The current does not flow from one wire to the other. But wherever you see a dot like this, you see dot like this, that means the wires are intersecting. That means the current actually flows through them. Okay, like this place and all, the wires are intersecting, so the current will actually flow through these wires. See, all these are intersections. Understood? Okay. Okay. So now see this. What now there is right now you have just the driver has just put the light here like this. Okay. So what happens? Okay. This is again there is no beam hitting the light sensor, so this output is 0. If this is 0 means what? V1 of AND gate is 0. V2 is equal to 1. That means output from here is equal to 0. That means this is 0. V2 is 0. That means the NAND gate gives an output of 1. Okay. Now see this AND gate. See this AND gate 2. It has got 1 and 1 coming in. So its output is going to be 1. When its output is 1, this high beam starts operating. Okay, this high beam is operating because once this is 1, see this wire is going here, it is 1 here. You understood? So that is the first criteria when the first scenario when the driver has just put the switch to high beam and there is no opposite vehicle coming which will hit a beam onto your light sensor. There is no beam hitting this light sensor. So then in that case you will get a high beam in your vehicle. Okay. Now we will see other scenario wherein the driver has put it in the high beam. Okay. But at the same time there is a opposite vehicle coming, which is hitting your light sensor. Okay, so we will see what happens in that case. Okay, just a moment. Let's see. Oops.
I will drink water and come.
No. Hmm. So now we have come to this drawing again, and what we'll do is we'll simulate a situation where the driver has selected high beam, but yeah, this driver has selected high beam. This is not there. Okay, so what happens, and there is an opposite vehicle coming, so that your light sensor, this is your sensor, this is your sensor also senses that there is a vehicle coming opposite. So you have one as input, and one here also. From the output of the sensor also you get 1. Okay, so now let's see where all that 1 from here shows up. Okay, you have this one as 1, V1 is 1 of the switch, and V3 becomes 1. Once V3 is 1, you have this one equal to 1. Once this is 1, your V1 is also equal to 1. You see, here it is connected. Okay, also this one V2 of and 1 is also 1. You got it? Okay, now let's see what happens with this signal. When this signal is coming, you know what, it turns V1 also equal to 1. So now that both the signals are equal to 1, the AND gate gives the AND 1, AND gate 1 gives an output of 1. Okay, and you have, once this one is 1, you have this also as 1. You got it? So both V1 and V2 of the NAND gate are 1, and once V1 and V2 of NAND gate are 1, you know the truth table of a NAND gate. You can refer back to that truth table. What does a NAND gate do? Its output becomes 0. Okay, its output becomes 0 because both V1 and V2 the inputs are equal to 1. So once this is 0, V2 of AND 2 also becomes 0 because it is the same line. Okay, V2 of AND 2 also becomes 0. So once V1 and V2, V1 is 1 and V2 is 0, the output from the AND 2 will be what? 0. You can check the truth table. The output will be 0. Okay. Once the output is 0, what happens to your V1, that is the input to your high beam light, that becomes 0. That means the high beam turns off. High beam turns off. High beam is off. The moment you get a light falling onto your sensor, your high beam becomes off. Okay, but when you are driving, you don't want the high beam to turn off and the low beam or to not turn on, right? So at the same time, your low beam should turn on also. Correct? Your low beam, when your high beam turns off, your low beam should turn on also. So how does it happen? So here we have given a NOT gate. Okay, so since this is 0, this NOT gate will make output as 1. Once this output is 1, here it is 1. Okay, let's see what happens here. Here this is 1, and since V2 is not connected, this is 0. This output is 1. It goes to here also it is 1. So once the OR gate or 2 senses an input coming, so it will do what?
1.
It will make it 1. Once it is 1, the low beam will
On.
turn on. Okay, so that is the function. So your circuit is functioning, so you can use this for your this is the logic for your operation of your light sensing mechanism. Okay, so I will send the truth table with, there are 4 scenarios that we have to consider. See, I will show the scenarios. These are the scenarios. Okay, what is the scenario 1? That is when the driver selects high beam and there is no oncoming vehicle. That is scenario 1. Scenario 2 is when the driver has selected the high beam and there is an opposite vehicle coming. Okay. Third one is when the driver has selected a low beam and there is no vehicle coming from the opposite direction. The fourth one is when the driver has selected low beam and there is an opposite there is an opposite oncoming vehicle. Okay, so these are the scenarios. So the inputs to various sensors and switches and all these things are listed here. Okay, and this section is where your final outcome of low beam and high beam is shown. 1 means on and 0 means off. Okay, so just remember that. And I will be sending this truth table with Laya. Okay, so you can check that. In that only the scenarios you have to might be refer to this video. There are 4 scenarios. Okay, these 4 scenarios you have to refer, or might be you can look at this video and take down a note. Okay, of all these 4 scenarios, and these are the various conditions, and this is your final output. Okay, so just ask me if there is any doubt. You can call me tomorrow. Okay, if there is any doubt you can call me, right? So that's all for this explanation. Is there anything, Radhu, anything else?
Can you explain the truth table by changing the numbers? No, there's only 4. Okay, no.
No, there are only 4 situations, no? So all 4 situations are listed here. So you can,
will change accordingly.
they will change accordingly, but there is no point, no, for us to, if there are many conditions, then we can keep the truth table. Okay, we can do like that. Okay, but if tomorrow when you are looking at this truth table, if there is any doubt, okay, you can call me. That time we will see how to solve it. Okay, okay.
Bye.
So nothing else. Best of luck for your presentation. Bye bye.